Hello everyone, myself Sneha Murthy, studying in Sri Venkateshwara College of Engineering from ISC branch. Today, the topic we are going to discuss about the basic principles of ANOVA in mathematics. First is the basic principles of ANOVA. Next is introduction to ANOVA. The ANOVA stands for analysis of a variance. ANOVA means it's an analysis of a variance. It is a statistical test used to compare the means of a two or more groups. ANOVA helps to determine if there are any significant difference between the group means. Here there are two types of ANOVAs, that is of one-way ANOVA and two-way ANOVA. Next is the basic principles of ANOVA. ANOVA compares the variation between groups to the variation within the groups. It tests the null hypothesis that all the group means are equal. ANOVA calculates the F statistics which determines if the group means are significantly different. This is the basic principle of ANOVA. First, the point is ANOVA compares the variation between the two groups. Next is it tests the null hypothesis, whether the mean are equal or not. Next, it calculates the F statistics, which determines the group means are significantly, which are very different. Next is one-way ANOVA. One-way ANOVA compares the means of three or more groups. The first, it uses one independent variable or factor to determine the group membership. Example, comparing the effectiveness of the three different fertilizers on plant growth. Here, the first one-way ANOVA, it compares mean of the independent groups. It preferable when three or more groups of the data, one independent variable and dependent variable. The independent variable should have three or more levels. It uses F distribution for the calculation process. This is the one-way ANOVA. And the next is two-way ANOVA. Two-way ANOVA compares the means of two independent variables simultaneously. It assembles the interaction effect between the two variables on the dependent variables. The example for this is investing the influence of a gender and age on the test scores. These are the things which we will learn in the two-way ANOVA tests in R, that is effect of two grouping variables. We will learn the definition, ANOVA assumptions, compute ANOVA in R, interrupt, post HOC test and check assumptions. This is an example in the diagrammatic way representation of a two-way ANOVA test in R. And the next is between group variance. ANOVA calculates the between group A variance by comparing the means of each group. It assesses how much the group means differ from each other. The larger the between group variance, the more likely the group means are different. Here is the graphical representation of between group variation and within group variation. The first is between group variation, the difference among the group means. So this is the diagrammatic representation, and this is the diagrammatic representation within the group variation. Next is within the group variance. ANOVA calculates the within group variance by measuring the variation within each group. It assembles how much the individual scores within the each group differs. The smaller the within group variance, the more homogeneous the group is. Next is between group variance. Between group variance, estimate of the variance between the group means it is denoted by S cap square, that is sigma of nj xj minus x bar divided by k minus 1. And the two sources are error variance and the treatment variance. The first one is error variance. It is uncontrolled and unpredictable differences among the individual sources. The within groups variance estimates the error variance. The variance among the group means that is due to the effect of one. This is the thing about the within group variance. This is the formula to calculate Next is F statistic calculation. The F static is calculated by dividing the between group variance by the within group variance. It represents the ratio of the variance between the groups to the variance within groups. A larger F value indicates a higher likelihood of the significant difference between the group names. This is all about the F static calculation, and here we take an example that is of ABC with values 3.54, 3.8, 3.5, and the B values as 3.9, 3.8, 3.7, 3.9, and the C values as 3.5, 3.3, 3.6, and 3.5. Is the evidence any treatment means differ from one another? So this is an example for a F static calculation. And the next is null hypothesis. The null hypothesis in ANOVA states that all group means are equal. The alternative hypothesis suggests that at least one group mean is different. ANOVA tests the null hypothesis using the F statistics and p-value. Here ANOVA, the null and the alternative hypothesis. ANOVA tests the null hypothesis, that is mu naught is to mu1 equals mu2 equals so on up to mu k. That is, the group means all are equal. Next is the alternative hypothesis is H1 is equals to mu I is not equal to mu j for some I equals j. This is about a null hypothesis. And the next is example for a one-way ANOVA. The question is next. Three teaching methods A, B, C are compared with 30 students in each group, and the null hypothesis, the mean test scores of three groups are equal. Here we can see the example. One-way ANOVA involves a single independent variable. This is mediation, counseling, and the diet supplement. Here we get a different mean values. So in this way we can execute a one-way ANOVA. And the next is another example. The F statistics is calculated by comparing the between group variance to the within group variance. If the value of F is significant, the p-value is less than 0.05, we reject the null hypothesis. A significant result indicates that at least one teaching method has a different effect on the test score. The ANOVA process at a glance. Say if you have compared average of the three samples to know if they are coming from the same population or not, then the step 1 you need to calculate between the sample mean variance. Next is two-way ANOVA. Does the type exercise and the diet plan affect the weight loss? So this is the question. Two independent variables, exercise A, B and diet plan X, Y. Null hypothesis, there is no interaction effect between the exercises diet plans on the weight loss. And the example is two-way ANOVA. Two-way ANOVA assess the main effect of the exercise type and the diet plan as well as their interaction effect. The F values for each factor and the interaction effect are calculated. If any of the F values are significant, it indicates a significant effect on the weight loss. And this is a table where how the two-way ANOVA is connected. That is source of variation, sum of the squares, degree of the freedom, mean square and the F naught. And the next is the final part of the conclusion. ANOVA is a powerful statistical test for comparing mean of the multiple groups. It assesses the variation between and within the groups to determine the significant differences. ANOVA can be extended to analyze the interaction between the multiple independent variables. And the final summary is ANOVA compares the group means using the between group and the within group variance. It calculates the F statistics to evaluate the significant differences. One-way ANOVA compares three or more groups, while two-way ANOVA assesses multiple independent variables. And with the graphical representation, the one-way and the two-way ANOVAs are represented. Thank you.